MathKlik.
Mabuhay! How do we graph quadratic function? What information can we get from the graph of a quadratic function? How do we determine the vertex and axis of symmetry of quadratic function from its graph? In this lesson, we will discuss how to graph quadratic functions. Recall that a quadratic function f is defined by f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a should not be equal to 0. This function and any other functions can be visualized through their graphs. Let's discuss how to graph quadratic functions. A function can be graphed by plotting points. These points are first determined by assigning values to the independent variable and then solving the corresponding function values. Let's illustrate this by graphing the simplest quadratic function f of x is equal to x squared. First, we construct table of values. Choose values for x that we can work on conveniently. Let's say -3, -2, -1, 0, 1, 2, and 3. Compute the corresponding function values for each x using the defining function f of x is equal to x squared. If x is -3, f of -3 is 9 and the corresponding point is -3, 9. If x is -2, f of -2 is 4 and the corresponding point is -2, 4. If x is -1, f of -1 is 1. The corresponding point is -1, 1. If x is 0, f of 0 is 0 and the corresponding point is 0, 0. If x is 1, f of 1 is 1 and the corresponding point is 1, 1. If x is 2, f of 2 is 4, the corresponding point is 2, 4. And if x is 3, f of 3 is 9, the corresponding point is 3, 9. Let's draw a Cartesian coordinate plane. Plot points represented by the ordered pairs x, f of x. Then, draw a smooth curve by connecting the points from left to right. Let's graph another quadratic function. This time, let's draw the graph of g of x is equal to -2x squared plus 12x minus 19. Again, we construct table of values. Choose values 1, 2, 3, 4, and 5 for x. Compute the corresponding function values for each x value using the defining function. If x is 1, g of 1 is -9. The corresponding point is 1, -9. If x is 2, g of 2 is -3. The corresponding point is 2, -3. If x is 3, g of 3 is -1. The corresponding point is 3, -1. If x is 4, g of 4 is -3. The corresponding point is 4, -3. And if x is 5, g of 5 is -9. The corresponding point is 5, -9. Let's draw a Cartesian coordinate plane. Plot the points represented by the ordered pairs x, f of x, and then draw a smooth curve by connecting the points from left to right. The graph of any quadratic function is known as parabola. The parabola of a quadratic function may either open upward or downward, depending on the value of a, which is the coefficient of the second degree term. If a parabola opens upward, it has a lowest point at h, k, and the quadratic function has a minimum value. Its minimum value is k. If a parabola opens downward, it has a highest point at h, k, and the quadratic function has a maximum value. Its maximum value is k. A parabola has two parts. These parts are separated by a turning point called the vertex of the parabola. Its coordinates are h, k, where h is equal to negative b over 2a and k is equal to 4ac minus b squared all over 4a. Remember the vertex form of the quadratic function? In a parabola that opens upward, one part consists of decreasing function values and the other part the increasing function values. In a parabola that opens downward, one part consists of increasing function values and the other part the decreasing function values. The parabola of a quadratic function is symmetric with respect to a vertical line that passes through the vertex of the parabola. And this line is called the axis of symmetry. This line divides the parabola into two congruent parts so that one part is a reflection of the other part. Since the axis of symmetry is vertical and passes through the vertex, its equation is x is equal to h or x is equal to negative b over 2a. Determine the coordinates of the vertex and the equation of the axis of symmetry of the function f of x is equal to x squared minus 8x plus 17. Then, graph its function. The coordinates of the vertex can be found using h is equal to negative b over 2a and k is equal to 4ac minus b squared all over 4a. That means we need the values of a, b, and c. Substitute these values to the formula for h and k. Since h is equal to 4 and k is equal to 4, then the vertex of the parabola is 4, 1. And the equation of the axis of symmetry is x is equal to 4. Take note also that the value of a is equal to 1, which tells us that the parabola opens upward. See how useful this information are in conveniently sketching the graph of f of x is equal to x squared minus 8x plus 17. Plot the vertex and sketch the axis of symmetry. Then let's find some other points of the parabola so we can draw the graph. Find f of 3 by substituting 3 to x in f of x. F of 3 is equal to 2 and the point 3, 2 is a point of the parabola. Now, reflect this point on the other side of the axis of symmetry. Its reflection is the point 5, 2. If f is equal to 2, substitute this to x in f of x. F of 2 is equal to 5 and the point 2, 5 is a point of the parabola. Reflect this point on the other side of the axis of symmetry. Its reflection is the point 6, 5. Find f of 1 by substituting 1 to x in f of x. F of 1 is equal to 10 and the point 1, 10 is a point of the parabola. Again, reflect this point on the other side of the axis of symmetry. Its reflection is the point 7, 10. Now, sketch the graph of f of x by connecting the plotted points from left to right. Determine the coordinates of the vertex and the equation of the axis of symmetry of the function g of x is equal to negative 3x squared minus 6x minus 5. Then, graph its function. Let's use a different approach in finding the coordinates of the vertex. Convert the given function form in vertex form. Group the first two terms together and factor out negative 3. The result is g of x is equal to negative 3 quantity x squared plus 2x, close quantity minus 5. Produce a perfect square trinomial by adding and subtracting the square of 1/2 of 2. The result is g of x is equal to negative 3 quantity x squared plus 2x plus 1, close quantity, minus 5 plus 3. Factor the PST and simplify. This gives us g of x is equal to negative 3 quantity x plus 1 close quantity squared minus 2, which is now in the form g of x is equal to a quantity x minus h close quantity squared plus k. That means h is equal to negative 1 and k is equal to negative 2. Hence, the vertex has coordinates negative 1, negative 2, and the equation of the axis of symmetry is x is equal to negative 1. Take note also that the negative value of a tells us that the parabola opens downward. Let's now sketch the graph of g of x. Plot the vertex and draw the axis of symmetry. Find g of 0 by substituting 0 to x in g of x. G of 0 is negative 5 and the point 0, negative 5 is a point of the parabola. Reflect this point on the other side of the axis of symmetry. Its reflection is the point negative 2, negative 5. Now find g of 1 by substituting 1 to x in g of x. G of 1 is negative 10 and the point 1, negative 10 is a point of the parabola. Reflect this point on the other side of the axis of symmetry. Its reflection is the point negative 3, negative 10. Find g of 2 by substituting 2 to x in g of x. G of 2 is negative 29 and the point 2, negative 29 is another point of the parabola. Reflect this point on the other side of the axis of symmetry to find another point. This point is negative 4, negative 29. Sketch the graph of g of x by connecting the plotted points from left to right. Now, try this. Draw the graph of h of x is equal to x squared minus 1. Compare your graph with this. Draw the graph of q of x is equal to negative x squared plus 2x plus 3. Compare your work with this graph. For more matitinik tips, just click MathKlik. And please, don't forget to subscribe and click the notification bell for our next video lesson. See ya!